Today in Capechi's Corner, we're going to look at proofs that are involving proportions. And looking at our first proof, we have a smaller triangle inside the larger triangle, and we know that angle 1 is congruent to angle 2. So I'm going to mark that angle 1 is congruent to angle 2. And I'm trying to prove that two of these pairs of sides are in proportion. So my first one is given, and I actually drew it in here. If you look down here, I drew the triangles again, because sometimes that's easier to see visually when you separate them. So I have 1 and 2 are congruent. I also notice in going back and forth between this diagram that has both triangles and them separated at the bottom, that angle J is a part of both triangles. So I can actually say in my proof that angle J is congruent to angle J, and that is because of the reflexive property. So I have it marked, my diagram at the top. I'm going to mark it at the bottom as well. And I notice because I have two pairs of angles that are congruent that I can say that these triangles are similar. So I can say triangle JIG is similar to triangle JZY, and that is because of angle-angle similarity postulate. Now again, I always have to be careful with the order. So I have J listed first, they match up. And then I and Z are both the angles that don't have a marking, so they match up. As well as G and Y, they both were the congruent pieces that we start with. So once I say that these triangles are similar, I can say that the sides are in proportion. So I can say that JG is to JY. So I'm looking at this side here and this side here is equal to GI over YZ. And that is because corresponding sides of similar triangles are in proportion. So that's all I really had to do for this proof to get to my final step. In our second proof, we're given that some sides are in proportion, and we're trying to prove that angle J is congruent to angle N. So if I'm trying to prove that J is congruent to angle N, I'm going to mark that. And if I can prove that these triangles are similar, then I can say that those angles are congruent. So I have a pair, and I'm going to mark what I have so far. I have JL is to LN. I'll use a different color for the other pair. Is to KL over ML. They're in proportion. I also notice that I have vertical angles here. So I have a pair of vertical angles here. So I'm going to mark that and write that in my proof so I have it. So I can say that angle MLN is congruent to angle KLJ, and that is because of vertical angles are congruent. Now because of that, I actually have the triangles are similar now. So I can say triangle MLN is similar to triangle KLJ, and similar to what we said in the last proof, we need to be careful that our letters are matching up to the corresponding parts of the other triangle, and that's going to be because of side-angle-side similarity theorem. I have a pair of angles that are congruent, and the sides that are including that angle are in proportion. So now once I say that those angles are similar, I can say angle J is congruent to angle N because of the fact the corresponding angles of similar triangles are congruent. And looking at our last proof for today, our given information is I have three sides that are in proportion, and I'm trying to prove that segment BC is parallel to segment AR. So again, in looking at that, I need to come up with a plan. If I can prove that those triangles are similar, and then I can say that I have a pair of angles are congruent, therefore leading to parallel lines, that's going to be my best bet. So I'm going to try that and see how that goes. So again, I'm going to mark what I have so far. So I have AB is to SR as BC is to RA. They're the sides that are going to match up there. And then my last set is going to be CA, so it's going to be this side here, is to AS, so the other side. So when I'm marking that, I notice that I have three sides in proportion. So I can actually go right into stating that these triangles are similar. So I can say triangle ABC is similar to triangle SRA. And again, I have to be careful the letters I match up together. And that is because of side, side, side similarity theorem. All three sides are in proportion. So now, in trying to prove that BC is parallel to AR, so I'm going to kind of extend that a little bit and see what angles are going to be helpful there. And I notice that if I can say that this angle is congruent to this angle, which I can, then I have alternate interior angles if I have some parallel lines. So I'm going to kind of proceed that way. So I can say angle BCA is congruent to angle RAS, and that is because of corresponding angles of similar triangles are congruent. And once I state that, now I can actually go right into my parallel lines. I can say BC is parallel to AR, and that is because if two lines are cut by a transversal, and alternate interior angles are congruent, then the lines are parallel.